This is our first lecture about general or basic physics. This is the course that we are going to have this year, and I will make lecture videos like this and upload in Moodle, so that you will be able to watch it anytime you want and as much time as you want. You won't need to be attached to the particular time of our lecture. We will write midterm. We will agree on the date later. Then we will have laboratory works. We are going to have the intensive course of laboratory works after we are allowed to come back to universities. And we will have exam. Exam will be, both exam and midterm will be in Moodle. So midterm can be in April, the beginning of April. Exam will be probably in June. We will see how this situation with coronavirus improves, and lab works will have it in the university when we are allowed to come back. That this may be in May probably. Okay, so general or basic physics. This is our course this year that I'll be teaching you. And this, in general, physics is a discipline that physics deals with matter. This can be a large scale or small scale, like large scale like universe, small scale like atom, like nucleus of the atom, electron, and even deeper, smaller. And matter is usually divided into two parts. It can be material or it can be field. Material, we are more aware what is material, and field is it can be magnetic field, electric field, electromagnetic field, force field, gravitational field. That's a bit strange to understand at first, but we will improve. The goal of physics is to discover patterns, some kind of patterns, and describe them by quantitative laws. This is equations. These are equations, yes? Quantitative laws that are equations, so that we could predict how processes proceed in time and space. Physics is experimental science, and all the laws are obtained from nature. And physics, general basic physics is usually divided into mechanics. Sometimes in the course of mechanics it's written mechanics and relativity, Einstein's theory of relativity, molecular physics, and thermodynamics. Then electricity and magnetism. By the way, you have all the information about all the notes of lectures that I've given you online, that I've given you the link to the page, internet page. There will be slides and lecture notes that we are going to follow, and I will just add some improvements to them and some remarks. So basic information is there, so you can read also. Then it is optics, and then it is atom and nuclear physics. Can be called quantum mechanics. Quantum mechanics. And usually relativity and quantum mechanics can be referred as modern physics in some books. Now, other things that are important here, this will be maybe philosophical, historical point of view, and now to get to more to things that is more, let's say, scientific, more. So we will begin with physical quantities. So physical quantities are basically divided into two parts. So they are scalars and vectors. So scalar has only magnitude. Vector has magnitude and direction. So only magnitude has mass. We can abbreviate it as m, small m. Then temperature, T, yes. Voltage, in some cases it's written like V, in some cases it is written like capital U, because voltage and volts, they have the same, would have the same abbreviation, so it would be confusing. So these are examples, and now vectors, magnitude and direction, it would be velocity. Velocity is, if there is no direction, there is speed only. So velocity would be speed plus direction, where the object is moving. Yes, so velocity is speed plus direction. Speed is scalar, direction is an angle. So that's all right like this. So it can be force, acceleration, and other things. Okay, so vector has, let's draw a vector here. So a vector is represented by an arrow, let's say force by 30 newtons. And also this can be represented as F. Magnitude of F is, it's written like this, with two vertical dashes. And 30 newtons. Now also there is given angle of F 45 degrees, let's say in this case, yes, 45 degrees. So magnitude and direction. Magnitude is always positive, so if you have let's say if one vector is pointing upwards, let's say it is F, it's vector pointing upwards, let's say vector F, and it is 20 newtons. The magnitude, vector F, angle of F is 90 degrees. So if you want to make another vector, so it will be, let's say, pointing downwards. So this would be this would be 20 newtons. This red would be minus 20 newtons. So you can write that this red vector is magnitude is 20 newtons, like the one like this, but you then write that angle, you can see that angle is minus 90 degrees. If you are comparing the angle to, so this is plus 90, this would be minus 90 degrees. Now vectors are usually drawn in some particular coordinate system. So next it is coordinate system, usually Cartesian coordinate system. It can be three-dimensional, 3D, then it has three axes. It will be Z, X, Y. This is three-dimensional, and if you draw a vector to somewhere from the point of 0 to somewhere in the space. So it is a three-dimensional vector. We can somehow show that it is three-dimensional vector. Three-dimensional, although it's hard to represent it like this. And also we can have two-dimensional Cartesian system. This would be y-axis, this would be x-axis. Vector is here. And it's two-dimensional vector. Okay, now what else? The other thing is that there are components of vector, and these components are in three different axes, as you can see. So the component of this vector would be on z-axis. One component is z, is just like you make a projection of this vector to each component, as you can see here, according to these dashed lines. The vector is looking at this point, so you make a dashed line here, vector end. You make a dashed line here, and you make a dashed line here to the z-axis. And now you have these three green components. So if this vector is f, so f vector, now it has three components. These components are scalar quantities. They have the unit of length. It would be 0, so let's say it's 2 meters, 3 meters, 2 meters again, okay, or this is 2.5 meters, this is 2 meters, this is 3 meters, but it is scalar quantity, so you have fx plus fy plus fz, but this is a vector quantity, so you need some kind of a vector to be here. So that's for this we add unit vector fxi, fyj, and fzk. So this is unit vector. When you multiply, it has vector I, j, k. They are unit vectors. So I, the length of I, is the length of equal the length of j, and is equal the length of k, and is equal to 1. And their direction is they are parallel to the corresponding axis. This would be vector j. This would be vector unit vector I. This would be unit vector k, parallel to the corresponding axis. And when you multiply each, let's say you have here, let's say it's 3 meters, okay? 3 meters, 1, 2, 3, and you multiply this 3, let's try to make it green, multiply on y-axis, so we have this, multiply 3 meters by j, unit vector j, so you have this whole has the quantity of vector. We can make it f, let's say with y, we can make this fz with vector, we can make it fx with vector. So this, when you multiply the component by unit vector, you get some kind of vector that add all these three vectors to corresponding to particular axis, and you get this vector f. So this is vector components. Now the same is with 2D, but I don't have here space, so I will shift to another page. So 2D drawing. So we are having a vector here. So let's take it has only two components. This is y-axis, this is x-axis. Vector f, it would have only two components this time because there's only two axes. So fxi, fyj. So again, fx, fy. So we take this vector to component on x-axis. We go from the end of the vector. This is the end of the vector, is the beginning, this is the end. From end of the vector straight down to the axis, we take this green scalar fx, go here. Now we go horizontal to y-axis, yes, because this horizontal line, dashed line, we take this green, this component. unit vectors are the same, I and j. So I and j. And when you multiply fx by I, you get, as we shown before, fx vector, let's say, or fy vector, and you add these together to get vector f. How to get these components, fx and fy? How to get these components? These are scalar quantities, so it is f magnitude of vector f, this vector, original, cosine alpha. This is magnitude f sine alpha. So component shows how much of a vector, how much of vector is in x-axis, and this correspondingly how much of vector is in y-axis. Because you take this projection down here and take this projection here to this axis. Now, how these vectors, you see this the sum, how these vectors are summed. So you see that in order to obtain this vector, we sum two vectors. We sum vectors fx, we have written like vectors fx, and we have written vectors fy. These are not components, these are components multiplied by I. Fx multiplied by I, we shown that it is fx vector. So when you add these two, how to add? Now, you can use rectangle rule. Rectangle rule, you draw a rectangle and the vector sum would be this. So this vector f, is fx plus fy. So in other words, if you have vector A, vector B, the sum, you draw a rectangle here, and the sum would be this. Vector C is A plus B. Another way to sum two vectors is you take the vector A, put vector B, the beginning of vector B in the place of the end of vector A, like this. So this is vector A, this is vector B, and you add A plus B, so from A to B you draw, so this is vector C, A plus B. So you take, put vector B to the end of put vector B beginning to the end of vector A. This arrow is from A, this beginning from B, and from B, and from, because you add A plus B, so from A you draw this vector to B. Here it is, you see the result is the same. Vector C is the same vector as here. Now, how to, this is vector addition or summation. How to add vectors, yes, add vectors. Here and also here, yes, add vectors. Now how to subtract vectors. Subtract vectors. For subtraction of vectors, if you have vector c is a minus b, then you write like a plus minus b, like this. And then if you have vector a and vector b, so what do? You change the direction of vector b like this. Change the direction, this would be minus b. Change the direction of vector b. So vector a, vector b, minus b. So change the direction of vector b and vector a plus minus b. So you just draw a vector here. So this would be vector c. So it's the same like this vector here. Vector c the same, yeah? So vector a, vector minus b, from a to minus b you draw a vector here, and you can show the same vector here, or you may not show it, it doesn't matter. You know the answer. Now, these things you probably should be learning in mathematical analysis. I'm just reminding you these things. Now let's go back. So another thing is scalar product. Scalar product of two vectors. Scalar product. So if you have two vectors, and this is vector A, this is vector B. So scalar product of two vectors is written like A times B with dot, and because it is scalar, so you need magnitudes of vectors, and cosine of angle between vector A and vector B. This is angle between vector A and vector B, cosine. So this part, B times cosine angle between vector A and vector B, it is the component or the projection of vector B in vector A. In vector A, this is subscript, A subscript. This should be A subscript. So this can be abbreviated like this, and this is what stays. This stays here, and this would be like this. Vector B projection in vector A direction. So this BA tells how much of vector B is in the direction of vector A. Okay, now what else? Units. Units, physical units, usually we refer to SI units. SI units, System International. So we have mass, international unit for mass is kilogram. Temperature, Temperature is Kelvin. Length meter. Time second. Quantity, it is mole. You know, from chemistry, molar mass and other things. Light intensity, it's luminous intensity. There are a lot of, it would be candela, a lot of units with light. Luminous intensity, light intensity, let's say. Candela, and one more missing, it is current, electrical current, it is ampere. And when you do calculations in the equations, use always these units. Don't use grams, turn grams to kilograms. Instead of degrees Celsius, turn to kelvins. If you have length in kilometers, change it to meters, and then you will not spoil any exercise or anything, any calculation. So then it would be good, because usually students forget to change this, to change grams to kilograms, or kilometers to meters, or hours or minutes to seconds. This happens. But if you change everything, will be okay. Now, errors. Errors, another thing is that our devices to measure temperature, measure any quantity are limited to the limitations of our devices. So we have always measuring things with errors. So there are two types of errors. Let's say it's written with delta M, referring to mass. It would be absolute error. So delta M, delta T referring to temperature, delta V referring to voltage. It's absolute error, and it also can be relative error. With this, this would be capital delta, I guess. As I remember, this would be delta small, and this would be relative error. Relative error. So the same corresponding like here. So these two types of errors. And if it is written like M plus minus delta M, T plus minus delta T, V plus minus delta V, it says that something is given with error, let's say 5 plus minus 0.5 kilograms. If it's given mass, if the temperature is given like this, 20 plus minus 0.5, it's usually given in Celsius, but as we said, kelvins are the units that you would use in calculations. So it says that your mass is ranging from 4.5 to 5.5 kilograms. Yes. So you subtract 0.5 from 5, and then this is the result of subtraction, this is the result of addition. 5 less 0 plus 5. So you can. Kilograms. Now here, it would be 19.5 from 20.5 degrees Celsius. And absolute error, is always equal to 1/2 of the lowest graduation of an appliance that you are measuring with. If you are measuring with scales, let's say to determine mass, so the scale graduation would be like this. This would be 0, 1, 2, 3, 4 kilograms. So the lowest graduation would be what? And your arrow, let's say, shows 3, that it's 3 kilograms, but the graduation is 1 kilogram. So you write m is equal to 3 plus minus what? Half of the lowest graduation. Lowest graduation is 4 minus 3, so it's 1 kilo, as you say. 1, 2, 3, so it increases by 1 kilo on each graduation. So half of the lowest graduation, so graduation is 1 lowest graduation, so half of it would be 0.5 kilos. So 3 plus minus 5 kilos. Okay, now relative error. Relative error is the ratio. So this is relative in relation to something. Is absolute error divided by the value, and it tells you how much the absolute error is big or small referred to the value, original value of the quantity that you have measured. It refers to as a true value sometimes, but true, if you can't measure anything, so true can bring ambiguity, and it's usually given in percent, so it's times 100. So we will be dealing with errors in LabWorks. Now about calculation and maths. So let's write the calculations in calculations, maths, mathematics. So I would like to give you are probably learning maths in separate course now, and I would like to give you some symbol. I was thinking to give you differentials and integrals to see, just for completion, you see, for to have everything, because but we won't use differentials and integrals a lot, but in mathematics you will be dealing with them. So I will try to somehow manage with simpler maths. So at first we would be dealing in mechanics with vector velocity. It is speed plus direction. Speed, because when something is moving at particular speed, but the direction is important also. Acceleration. And so let's say we have these two things as vectors. So we would like to, here we would like to deal with only magnitudes for this, and we'll be dealing probably mostly with magnitudes. So let's write like we take let's understand that magnitude will be V without arrow sign, so it would be magnitude. So V could be given as the change V2 minus V1 So this would be delta V. Delta V is not here, not error or anything, but it is delta. It means the change, V2 minus V1, the same as you would have delta T, T2 minus T1. The same as you have distance, delta S, S2 minus S1. Acceleration, delta A, A2 minus A1. So let's say with time, it's maybe if you are calculate if something is occurring at, let's say, axis of time t, and you have here 2 seconds, this is 10 seconds, let's say. So what is delta t? Delta t will be, here is t1, here is t2, so 10 seconds minus 2 seconds would be 8 seconds. So delta would be this. Time is scalar quantity, distance here is also scalar quantity, but distance in some cases you can give it vector quantity, maybe not for distance, but some kind of association with position, but in more advanced cases where we will not be dealing with this. Now we'll be dealing a lot with the velocity, all this, or the magnitude of velocity, that is speed. Speed would be V average speed. If you know that you have traveled, it's written like average speed is the change in distance divided by change in time. So if you have traveled your let's say your distance from 2 seconds, you are traveling some kind of distance, and from 2 seconds to 10 seconds, your distance, this would be like S, your distance increases from travel distance from 5 meters to let's say 21 meters. So then from 2 seconds to 10 seconds, so what was your average speed? So then you do what? 21 meters minus 5 meters, 10 seconds minus 2 seconds, and it is what? 16 meters divided by 8 seconds, so it is 2 meters per second. So V average is delta S delta T, and it is like here S2 minus S1, T2 minus T1. So S2 is this, S1 is this, T2 is this, T1 is this. So this would be average speed. Okay, now another thing, average acceleration. A average, it would be like what? It would be like delta V, delta T. It's given like this, so it would be V2 minus V1, T2 minus T1. If you are traveling, if your speed changes to 10 meters per second to 2 meters per second, it means you are slowing down, and it takes for you time from 5 seconds to 3 seconds. So it means you have 8 meters per second per 2 seconds. And it means that you have 4 meters per second per second. It is 4 meters per second square. Means that per second your speed changes by 4 meters per second, or 4 meters per second square. So it is average velocity. If you want to find delta V from this equation, you just multiply by this cross. So it would be delta V would be A average time T. We will not be writing average, we will be writing delta V is just A times T. Here it would be delta T, yeah? Okay, like this. Or we can write like V is A times T if time calculation started from 0. Let's say if you have if T1 is equal to 0, yeah? In this case, if T1 equal to 0, V1 is equal to 0, because then this part, instead of 2, there is 0, so 10 minus 0 is just 10, so we don't need these deltas. So you will be dealing with this in maths, but here we're going to use something. Just don't be scared. I will explain there in more detail. This is not very difficult part. With this part, what is more scale to you, V average. This V average, we also have V instant. So V instant, there can be instant time, that this is average time, that you travel a lot distance, you divide that distance by time and you get average speed. Instant speed, you can, when you're driving with your car, you're driving, let's say, from Kaunas to Vilnius, the distance is 100 kilometers. But when you are driving with your car, you are driving at 90 kilometers per hour, 100 kilometers per hour, 110, 80. So your speed is changing. So the V instant is different from V average. So V instant is described as the derivative of distance S with apostrophe T, distance as a function of time, and it is and V instant would be the derivative of distance in respect to time. This will be given in maths by ds dt, referring to the same derivative, or it can be written as limit as dt decreases to 0, delta as delta t. When your time, delta time, average delta time, change in delta, not average here, change in delta decreases to 0, your delta S comes down to that particular instant, very small change in distance, and this refers to average speed. As you can see here, average speed, and your average speed when your time becomes very short, your average speed is the same as instant speed. So, but you should know that it is V instant is the derivative of ST, and that's enough. And A instant acceleration would be the derivative of Vt, of the speed. And if you want to turn around here you are searching for A instant or V instant, but if you have this and you want to find ST and Vt, you need to do integration. So this will be learning in maths. I will try to avoid it because it's general physics. Okay, so we can write here that S is distance, also T is time, what we are dealing with. Okay, and another thing, wanted to give a separate lecture, but I just then thought that would be a very short lecture, so I would add everything together. So it would be like not such a introductional part, but it would be beginning of mechanics, and we will be dealing with Newton's first law. So let's begin with mechanics. So mechanics. And mechanics is usually divided to two parts. It is kinematics and dynamics. Kinematics is the description of how objects move, usually in terms of simple mathematical equations. Dynamics is the study of what causes objects to move. So kinematics is dealing with coordinate systems. It is dealing with V independence on T, A independence on T, and other things. Now, kinematics would be dealing with Newton's first law, Newton's first law, let's see. And Newton's first law it is the same as it was developed by Galileo in the 16th century, and it can be written as Galileo's principle of inertia. So it is developed in 16th century by Galileo. Aristotle said that natural state of any object is rest. Aristotle in very beginning, I don't know the year that he was living, but it was said that objects, Aristotle, he was living around I don't know, before BC, maybe after AC. I can't tell you this, but we can look. But very early thoughts that the natural state of object is rest, and they move when they are pushed or something stops them moving. But Galileo said that Aristotle was wrong. So Galileo's principle of inertia is he developed these statements. He developed a statement that the property of the object to resist any change in the state of motion. So this is inertia. He developed a statement of inertia that it is the property of the object to resist any change in the state of motion. This means that a body at rest tends to remain at rest. A body in motion tends to remain in motion. So these were statements and thoughts that Galileo has. Maybe these were not thoughts, just the conclusions from observations and that Galileo produced. And the measure of inertia is mass. If object has mass, the bigger mass is harder to move, so it tends to remain at rest. If the object with mass is already moving, then it's the bigger object, it's harder to stop that object. So this is Newton's first law and Galileo's principle of inertia. These were taught by Galileo, and Newton has described them in such a in different formulation, but the idea is the same. So Newton's first law, it says that if with no force applied, the body is at rest or is moving with constant speed in a straight line. So if no force is applied, the body is at rest or is moving. So it means that with no force applied, the body can move. So that there was Aristotle wrong, because he thought that objects can move only when force is applied. But objects can move with no force applied. So, but they move with constant speed in a straight line. So constant speed plus straight line, it tells you what? It tells you that velocity v is constant. Velocity is what? Velocity is speed plus direction. In order for velocity to change, speed can change, magnitude, it means the magnitude. Speed, it is the magnitude of velocity. Magnitude of velocity. So it can change from 20 kilometers to 30 kilometers, or you can make or you can be turning at 30 kilometers. Maintain 30 kilometers, but make a turn. And then direction changes means velocity changes because direction changes. For velocity to change, either speed changes, direction remains the same, or speed remains the same but direction changes. So it means that anything can change, but if v is constant, we say that constant, so it means that speed is the same, direction is the same. Straight line, speed the same, direction is the same. Straight line. And it means that if v is constant, so what happens is if v is constant, so then acceleration is equal to 0. So acceleration, v is constant, acceleration is equal to 0. If you have v, so how is delta v calculated? Delta v is calculated by ds dt. We agree on this, okay? How is acceleration calculated? This would be s2 minus s1, t2 minus t1. So delta A would be delta V, delta T, and now if would be V2 minus V1, T2 minus T1. So if acceleration is constant, so it means there is no change. So if acceleration is 0, V is constant. So acceleration is 0, V is constant. So if V is constant, it means that V2 is equal to V1. If V2 is equal to V1, let's say 5 meters per second minus 5 meters per second, and this, the result is what? It is 0. 0 you can divide by anything. So that means that if V is constant, you subtract the same values here and you get acceleration 0. So it means that if you move with constant acceleration, with constant speed, acceleration is 0. Constant speed, acceleration 0. Okay, constant speed, acceleration 0. Remember this is correct. Now, we can write this, so once again, constant speed, no acceleration. Okay, once again we can write this. So how, first of all, how Galileo came up with this idea. At first it was Galileo who came up with this idea, so that that object can move in a straight line at constant speed. How did he came up with this idea? He thought that if there is an object sitting, let's say, on a table, some kind of object is sitting on a table, you push this object with force F, you push this object, but it moves, but then it stops moving. So what happens? Why does it stop moving? It stops moving because the friction, F push here, F friction is acting in opposite direction. So it's it's opposing the motion. So if you remove the friction, let's say by adding some liquids that remove the friction, some oil or something on the table, then it moves much more, that object. So it means that if you remove the friction, the object can move. So Galileo said if you totally remove the friction, then once object is pushed from its rest position, it will move forever at constant speed in a straight line. That's how Galileo came up with this idea, and he proved this by removing the friction using some kind of liquids, and he also did experiments with inclined plates. Like he was trying to let the object go on inclined planes. And so the object can move in a straight line at constant speed when there is no force applied. So that's where Aristotle was wrong. So again, Galileo was dealing with the things that we have discussed before. He was dealing with acceleration, speed, let's say velocity or speed. He was dealing with distance and these things that we have already discussed. So he was dealing with mass also. So here we are in Newton's first law. Newton's first law, or Galileo's principle of inertia, because this Newton's first law was originally developed by Galileo, and only Newton discovered other two laws, and he just combined them together to make this comprehensive, detailed explanation. So usually what this Newton's first law, he's dealing with constant speed, constant velocity, let's say, because the direction also doesn't change, constant velocity, and there is no acceleration. So for this, to summarize all these things, kinematic equations are given. Kinematic equations. So we can write these things in some kind of in equations and draw graphs. So there is no acceleration. So we can make a graph. Here it is t, time. Here it is 0. Here it is acceleration and dependence on time. And acceleration is 0, so it is, the curve is here on 0. So here it's acceleration because acceleration in time is 0. So here's the curve on 0. Now what's happening with velocity or speed? Velocity is constant. So this is the function, dependence, or graph, how you call it. These are synonyms. So v in time, speed or velocity is the same. So here we are dealing with only with speed, okay? Because direction, we are simplifying the situation because it's basic physics. So general course. So in time, velocity is constant. Speed is constant. Here speed is Vt is constant. So it is constant. It is a straight line here. That does not change. If it's 3 meters per second, it sustains 3 meters per second. Now another thing is position. Position is not a distance. It's referred to distance, but it's not the same as distance. So it's t, and it's xt. Xt is position of the object. Position. So here would be the initial position, some kind of initial position, and then it moves in a straight position increased by a straight line. So the equations, AT is 0, constant. Zero, VT is constant now. VT is constant. VT is constant. XT is what? XT is X initial plus what? Plus V times T. This V goes here because it's constant, because V times T is what? Is the distance that the object has moved. So let's now add everything together. Distance this VT refers to distance S. So in kinematic equations, the position is given. So this refers to S from T would be distance. So it is distance, V times T. So ST is V times T. So it's distance. So let's say now that you are moving, that you have x-axis. This is x-axis. You are moving along the x-axis in a straight line because it tells you that there is constant velocity. So in straight line. So your initial position is at 2 meters. You start by moving. Here is, let's draw a human here, and he is moving in a straight line here to the right. So this would be 1 meter, 2 meters, 3, 4, 5, and he is finishing the movement, let's say, at this position. Here it is his destination. Okay, so let's mark it by green. It is his destination. So now initial is 2 meters, and he's moving at constant speed. So speed is constant. So here his x initial is 2 meters. He's finishing at 5 meters. Here is 0. So beginning at this point, finishing at this point. So x initial would be 2 meters. Coordinate, position or coordinate, sometimes referred as coordinate. Initial is 2 meters. Finishing at 5 meters. So it means that this would be distance. Distance that he traveled. And the distance would be, distance ST would be V times T. The speed by which he traveled, let's say he moved here at 1, was moving at 1 meter per second, 1 meter per second, and he was moving, let's say 1 to 3 seconds. Okay, let's say he was moving 3 seconds here. Okay, times 3 seconds. So these cancel each other out, and we have 3 meters. So you see now he's finishing at 5 meters. So position or coordinate is given by xt. Distance is given like this, v times t. So the general equations, so the general pack of equations is for the motion with constant velocity, no acceleration, is that acceleration, there is no acceleration. Acceleration is 0 in time. Time passes by, but acceleration is 0. Vt is constant, xt is x initial plus v times t, and vt is st, so st is v times t. So here's the pack of equations that are summarizing this Newton's first law or Galileo's principle of inertia. So these are the things that I want you to know from Newton's first law. Maybe don't go so deep into these details, mathematics and all this. Just know that first law, there is constant velocity, no acceleration, constant velocity, and you have some initial position, and you move by constant speed. Time passes, and you travel the distance st, like this simple example. So thank you for listening, and this is the first lecture. We will continue later with other laws.